All right, let's start chapter 3. This chapter 3, section 1. The way the book's titles this section, it calls it measure of center, which is not correct. It should be titled measure of central tendency. It's how, what that means is how your data works around being around a center number. And that's what this first section is about. Yeah, we have two parts. We're going to look at the basic stuff first in part one, and we'll go a little bit more in-depth stuff in section 2. The 3 types of measures of central tendency. The first one is called the mean. The second one is called the median. Third one is called the mode. These are used to describe the pattern of the data. Because you've heard of mean before, haven't you? I hope. What does it mean? Average. The symbol we use for average, everybody knows how to find the average. Add up all your data, divide by how many you have, that's your average. The symbol we use for this is it's called the X bar. Why do we call it X bar? Well, I'll go and first put these 3 down, and I want to ask you again. So whenever you see the X bar, that means the average, the mean. The median means what? If you think about it, what do you call that thing in the middle of the road that sometimes you hit if you take a turn too short? It's called the median, because it's in the middle of the road. It's the absolute top dead center of the middle of the road. That symbol is called X tilde. TILDA. Tilde. TILDA. Tilde. And the last one is mode. What is mode? Yeah, if you think about in fashion, they called the mode couture is the most frequently worn style of that dress. That's called the mode. Most frequent. And that one is represented by something called X dot. Remember, mathematics is a symbolic language. You can't put XXX for everything. So we use these to separate what they mean. Why do we have X on the bottom? What does X represent? What? Not X in this case, because this is not a graph. Yeah, X equals our data numbers or elements. So whatever we collect, that's our X's. So since X is our data, X bar is the average of all our data, X tilde is the median of our data, and X dot is the most frequent of our data. All right, let's look at one by one. Let's look at the mean. Again, it's the average. X bar. I can use any one of these names when I want to talk about this thing. Let's look at the properties first. Sample mean is drawn from the same population but tend to vary less than other measures of central tendency. What does that mean? The sample mean is drawn from the population, but it varies less than the other measures of central tendency. What are the other measures of central tendency? I just listed them up on top. The median and the mode. So the mean varies very little from what it actually is. It all depends on the data you select from the population. And there is a way we separate population from the sample in symbolic languages too. The second property. When you calculate the mean, you use every data value you have in your data set. Extreme values tend to negatively offset the true value. Of the mean. What do I mean by extreme values? No, it can be part of the data set. Yes, which are outliers, yeah. Which are outliers, yeah. By extreme values, I mean outliers, yes. So in other words, if you have all A's and you make a 0, it will take you 5 A's to bring it up to a B or a C. That's why zeros are a kiss of death in school. So that's what I assume. If I make a C on this test, I can make 3 A's to bring it up to a B. So that's what I'm saying. Extreme values, if you have outliers, that can negatively affect what your calculations are, which means that the mean is not resilient or resistant. What's that? How do you mean? You mean? I know that's what I was thinking of another one. Which tells us, yes, which tells us or shows us that the mean is not resistant. What does resistant mean? The presence of an extreme value can offset or change the value.
Grades always been or like the average?
Yeah.
Have they used
The grades in the class to calculate the average of the class, yes. They use just the average of the test grades or the homework and test grades, like I do in this class. All classes do. Or some professors look at like the homework is worth 20% of your grade. So if you get a 80 of that, 80 in that, so it's 20% of 80 is your grade. Then if your test of each test is worth 10%, then you take 10% and add them all together, and that's your final grade. Yeah, or instead of a percent, use decimals. And it's you can do that, but why? I just use an overall. Here's everything. Everything's counted 100 points, and it's here's how overall how it looks. But when you take your final grades for the semester, the school then uses a weighted average because A's count 4 points or 3 points, B's count 2 points, C's, D's, and F's. A's can count 3 or 4 points. Why? Yeah, if it's a 4-credit course, then it counts 4 points. If it's a 3-credit course, it counts 3 points. But a B counts 2, C 1, D, and F. Those usually D is as good as zeros. So yeah, those are called weighted. And we'll look at that at the end of this section. All right, let's look at the differences when we calculate the mean. Let's look at some differences in what these things mean. Let's look at the symbols. What does that symbol mean? Which means yes, it does mean sum or summa, but sum means add up all the data points. That's what sum means. The sum of what? What does X represent? That's your data value. And I'll show you exactly what we mean by this when we look at how the symbol here and how that, what it really looks like. But I took away some stuff in there to make it look less difficult. But I'll show you what it really means in a second. What does that mean? It means mean. It is X bar, yes, because there's a bar there, but that's what it means. It means the average. What does N represent? Just sample? For example, in this class, N equals 6. Sample size. It's how many pieces of data you have. in your sample. Then what would capital N be? Population size. Here's the calculations for it now. The mean is calculated by adding all of your individual data points and you divide by how many you have. This is the formula, how it's traditionally written. Actually, instead of 4 here, it's really an N. Because what this means, I is our counter. It starts at 1 and it goes N. What's our N if we had this many data? What's our N? Yeah. 4 is our number of data points we have. So how do we read this? The way we read this, you notice this X. This X represents our data points. Here is our data set. Let's say it's 3, 5, 7, 9. That's our data set. These are all labeled. This was the first data set we picked. This was the second. This was the third. This is the fourth data set, right? It's, in other words, if I say, what's the fourth number in the data set, what would you look at? The fourth one is this one, is 9. What's the second? Yeah, so what these represent, so X sub 1, it represents 3. X sub 2 represents 5. X sub 3 is 7, and X sub 4 is 9. Because you have to have a way of identifying any piece of data in your data set. You're actually assigning locations.
So it just back to word. Code.
So what this symbol here says, what this sigma means summation, right? So here are my X's. What is my first I? I is set to 1. So it's X of 1. Then it's plus semi-summation. What's the next one? X sub 2. Then what's the next one? X sub 3. Then X sub, it stops at 4. So it starts at 1 and it goes to 4. 1, 2, 3, 4. And I add all those numbers in there. So what is X sub 1? X sub 1 is 3. X sub 2 is 5. X sub 3 is 7. And X sub 4 is 9. So that's what it tells us. That's how you read it. Right. Because you don't always have to start at 1. You can start at 0, or you can start any number you want to. You can choose wherever you want to start. I does not have to start. I starts at 1. That's the beginning. Whatever's down here is the first value. This is where you start. And this is where you end. I. And E looks like this. And E looks like that. So, and then N, remember this number here is where you end. So the number here is always your N. So if I divided this, I would divide by 4 to find the average. So now you see why we don't put the other stuff in there for simplicity purposes. It's simply implied. You start off at the first data set and then go on until you finish all of them. And you add them all up together. It's just implied. Again, this is one of the things I don't like when the other instructors, they don't teach you the math symbols, which you have to know it because not all textbooks are written this way. 99% of them that deal with statistics deal it this way. So you can see what you're dealing with. So far, so good. So everybody okay with the symbols? These two symbols deal with the sample data. Yes. Is it accurate? Because remember, what are we trying to do in statistics? We're trying to estimate what the population deals with. So this is just a sample. The bigger the sample, the more accurate you become, but you're still just taking a guess of a small portion of it. Case in point, the weather forecasts. If we interview the 20% of the people that were forecast to have rain, they're going to say we had rain today. So the sample says 100% of people said we had rain. But is that a true sample of the population? No. So how do we distinguish between sample and population? So this is the mean, and this is the data. Oops, sorry. When we deal with population, we deal with mu. This is called the mu value. Actually, if you want to make it more accurate, mu bar. It's the population average. In other words, if you start using the Greek letters, that represents the population. That's read in mu. So now when we calculate the mu, because it is of the population, we cannot use little n. So what do you think we use? Then we use population size. So the formula for mu is the summation of all your x's over capital N. So far, so good? Good. Mathematics is a language. We have to define the words, the syntax we're using in our language. And that's what I'm doing here. So if I gave you a report and it had this, What can you tell me? If I just gave you that bit of information, what can you tell me? So what number would you look at? Which one would you go by? Which one's more accurate? We know the sample size is 350. Which average? These are both averages. Okay, who would go with this number? Because it looks nice. This is of the population. This is the exact number we're looking for. Population is always more accurate than a sample. Because remember, a sample is trying to approximate a population. Population is the population. So just because it looks more impressive doesn't mean it is. It's just not enough information. But the average you're looking at is 7, whatever the numbers are. So whenever you have a population sample, use that. Population information, use that. Any questions so far? Right, so it's the symbols, the letters you use. If they're Greek, then they're population. Those are the most accurate you can get. The next one we're going to talk about, the median. You could think of the median as the middle of the road. The properties of this. The first one. The median does not change by large amounts when extreme values are used. Meaning it is resistant. Remember what resistant meant? Resistant, it means it's not affected by any outliers. Does not directly use all of the data values. The reason for this is we're looking for the middle number. There's very little math here. Remember, the median is also X tilde. To make sure you remember. So how do you calculate? This is a process. It's not really mathematical. The only math here is something that you've used all along. First step. Arrange your data in increasing order from smallest to largest. Why do we do that? Yeah, because we're looking for the middle number of the whole data set. Yeah, but do you want to increase in order better? Remember, you're trying to find the middle numbers. So how do you normally look at data in increasing order? So yeah, you set them in increasing order. But if you were to graph it, you would graph it left to right, not right to left. So now is where it gets complex. Second step, n divided by 2. Why do we do n divided by 2? To get the middle number. But two things can happen. If n is odd, as opposed to if n is even. Well, I'll get to it. If n is odd and you divide by 2, what happens? No. Remember, your data points are just data points. Because we're looking for the location. This looks for the location of the center value. So can the center be a decimal? No. So if we have an odd number, let's say 7 divided by 2, we get 3.5. It'll always be either 0.5 or 0. Whenever you divide by 2, it's always going to be 0.5 or 0. If it's 0.5, round up. That is the location of the median. Remember, if we had 7 pieces of data, 1, 2, 3, 4, 5, 6, 7, and we divided by 2, we get 3.5. So we rounded up, that becomes 4. It's the 4th location. 1, 2, 3. This is my middle number. There are 3 numbers here. There are 3 numbers there. It is by definition the middle number. So if you have an odd number of data points, you're always going to have a 0.5 surrounded up, and that's going to give you equal number of numbers to both sides. If n is even, let's say 6 divided by 2, we get what? What's 6 divided by 2? So 1, 2, 3. Is that the middle number? No, because you only have 2 here and you have 3 here. So if you have an even number and divide by 2, go to that location and get the number of data value. So I go to the 3rd location, get the data value. Go to the next location and get that value to the right. Yeah. The next location to the right. Yes. Because if you look at it, we have two numbers here and two numbers here now. Add those two numbers and divide by 2. So your median is going to be the average of your two center values. So it's going to be somewhere here. So for example, we have 1, 2, 5, 5, 7, 9. We have 6 numbers divided by 3. Divide 2, we get 3. 1, 2, 3. So I take this number, 5, add the next number to the right to it, divide by 2. So the median of that set is 5. So in other words, the median doesn't have to be a value from your data set. It doesn't have to be the data value from data set. It can be, but doesn't have to be. Does the mean have to be a value from your data set? Nope. Because remember, how do we find it? We add how many numbers we have and divide it. So in other words, we don't even look at the data set. We just count how many we have. So far, so good. And then the third one is the mode, or X dot. It's the most frequently occurring piece of data. And here it's properties. The mode can be found with qualitative data. A data set can have one mode, 2 or more modes, or no mode. If you have 2 modes, then it is bimodal. Then it's bimodal. What does bi mean? Two. So that's two modes. Depending on the size of your data set, if you had only 10 numbers and you had 3 modes, do you really have a mode? So when you have 10 pieces of data, if you have 3 modes, that's 60% of your data points are modes. So then that's where you say you have no predominant mode. So if you have a small number of data sets, anything more than 1, maybe 2 would be too many. So you don't have a predominant mode. It's just a data set. But if you have 100,000, you can have 4 or 5 modes that are most frequently occurring. But they all have to have this exact same value. The same number of repeating numbers. That's what a mode is. So remember, it's the most frequently occurring. Yes, again, mode couture is the most obvious example of it. Let's look at some examples here. In data set 2, the airport data speeds. Find the mean of the first 5 speed datas of your cell phones or small phones or Verizon. Find the mean. So how do you find the mean? So we get 38.5 plus 55.6 plus 22.4, 14.1 plus 23.1. Add them all together and then what? Divide by how many do we have? So what does that equal? What? Here's 36. Before? Before. Yeah, it's 2 left. 37.4. See, 5 goes into 15 3 times. 5 goes into 37 7 times with 2 left over. It makes it 0.4. Is it right? What'd you get? What'd y'all get? 30.34? Stupid calculator. Stupid brain. Stupid brain. Pretty easy. Yeah, these are small data sets too. So as we get bigger, of course, I'm expecting y'all to use software. Here's another example. Find the median. What's the first thing I do to find median? So the smallest is 14.1, then 22.4, then 23.1, 38.5, and then 55.6. We have 5 pieces of data. Divide that by 2, we get 2.5. It's 2.5, so we round it up to your third location. There's your median. That's your middle number. So far, so good. Let's change it up a bit. Let's do this one. Since you're asking for the median, you have to put it in increasing order. So the smallest is 14.1, 22.4, 23.1, 24.5, 38.5, and 55.6. We have n equals 6 divided by 2 equals 3. 1, 2. I go to the third one. I get that number. This is the third number. Then I go to the fourth one. I get that number and add them together. Because the median has to be between those two numbers. It's 47.6. 2, 3.8. 23.8 is my X tilde. Is 23.8 part of your data? No, but it tells us that it's between two separate sets. So we have an equal number of data sets to both sides, that we have 3 on each side. Again, if you have an even number of data points, you know you have to take the 2 middle points, add them together. If you have an odd, round it up, and you go to that location. Okay, find the mode of this one. Because we have 3 of those. So the mode is 0.3. Because it occurs 3 times. By definition, what is the mode? most frequently occurring, right? So if you think about it, we have our data set. Our data numbers are 0.2, 0.3, 0.6, and 1.2. If we take the frequency of all those, so how many 0.2s do we have? How many 0.3s? 0.6 and 1. So by definition, once you create the frequency distribution, you can see the biggest number is your mode. And that's the way we have to do it for larger sets of data. So yeah, let's say even if I had 10 or 20, it'd be too much to try to cross them out, create a frequency chart from there. So. Okay, the next one is a calculation called the mid-range. Well, your book calls it mid-range. Call it the midpoint. The formula is just this. Smallest data value plus the largest data value divided by 2. So what it's looking for is looking for the center of the actual data itself. Not the number of data, but the actual data itself. What is the average of all your data? Not the average, but the midpoint of your highest and lowest values. And the properties. It's to find the center of the actual data relative to the data values and not the number of data values in your set. What value is this hopefully close to? It's just the midpoint. Not the median, the average, yeah. You compare it to the average of your data set, see what you get. If you use it for the median, it could really throw you off because the median is organized by the increased set of the data folded in half. Doesn't mean it's actually going to be the middle. So this is one of our first steps we're going to do in the next part of this chapter is fitting how far does the values go from the center point. I call that variance and deviation. That'll be the next part. Here's an example. Find the mid-range of this data set. So what two numbers do I use? Use the smallest and the largest and divide by 2. $34.85. This brings us now to rounding off your final answers. So the mid-range, so it tells us the middle, what was the average of our numbers, remember? Oh, so that's right, that's what from there. So it's pretty close, actually. Pretty close. It's certain standard deviations away. Now, when we talk about rounding, the mean, median, and the range always have one more decimal place than your data set has. Typically, your data set will have one, maybe two decimal places. Your final answers for the mean, median, and midpoint, mid-range, will have one more than that, if possible. So the number of decimal points, decimal places, if your data has two decimal places, then your mean, median, and midpoint or mid-range will have one more. And the mode you leave it what it is because it is the frequently occurring number. So the mode, don't touch it. Just leave it as is. Next part, beyond the basics of measures of central tendency or measures of center. Working with frequency distributions. What is a frequency distribution? There's measures of central tendency. What is a frequency distribution? Okay, I'll tell you what. Here, let's look at this. Here's an example. There. How many of each do I have? How would you tell me that? Now we create a frequency distribution. What are our possible values? It was all the way up to 9, because there's a 9 there. Okay, so what's the next thing I do? If I give a bunch of data, I have this. How do I tell them how many I have of each? Which do what first? The tally column. We have a 2. We have a 4. We have 2 1s, a 5, 7 2 6 4 1 8 5 3 9 1 1 5 7 6 8 4 5 9 5 4 6 1 6 5. Now we'll create our frequency column. 6 2 1, 4, 6, 4, 2, 2, 2. How do I check to see if that's correct? Add them up. 10, 20, 22, 24, 26, 28, 29. And they count our data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. And that's how we have. So that's my first checks and balance. So it's easy here. Do we have a mode? We have a bimodal because we have this one's a mode, this one's a mode. So our modes are 1 and 5. It's bimodal. What's our median? How do you find your median? Well, we did that already. When we do this, we've already arranged them in increasing order. So we have 29 divided by 2 makes it 14.5, which rounds up to the 15th number. What I need to do is, where is the 15th number? To do that, I find what's called a cumulative frequency. This is the cumulative frequency. It's found by keeping a running tab. So the first one has 6. This one has 6, this one has 2, so there's 8 total here. Plus 1 is 9, plus 4 is 13, plus 6 is 19, 23, 25, 27, 29. So it keeps a running total of how many numbers I have. Everybody okay with that? Cumulative frequency. So I start off with this first one, then add that, then add that, then add that, and keep on going. It's running total. I need to find the 15th number. The 15th number is bigger than 13, so it has to be in this group. Because this group here has the 14th, 15th, 16th, 17th, 18th, and 19th number. So that number is a 5. My median is a 5. How do we find our average? Add what? Besides that, we have 29 pieces of data. What we have to do is, we know we have 6 ones, right? So it's 1 plus 1 plus 1 plus 1. What's another way we have to do that? Is so the X value times the frequency. So 1 times 6 is 6. 2 times 2 is 4. 1 times 3 is 8. 4 times 4 is 16. 5 times 6 is 30. 6 times 4 is 24. 7 times 2 is 14. 16, 18. Because I know I had 2 9s, so 9 times 2 is 18. I had 2 8s, which is 16. I had 2 7s, I had 4 6s. So multiply the frequency times the X, the actual data. So it's 40, 50, 80, 90, 110, 128, 131. So my average is the summation of X times F over N, which is 131 over 29. Remember what the rule just said. Your mean, median, and mid-range will only have 1 decimal more than your data set. How many decimals does the data set have? 0. So I just need 1 decimal place. So it's 4.5. If I lost you, now is the time to ask until you, because if you go home and try to do this and you're stuck, you're not going to do too much. So now's the time to ask you any questions. Okay, let's look at another example then. Find these for me. With this data set.
How do we do it? This 35 to 130.
Good question. Whenever you have a range of data, class of data, you have to find the midpoint of each class. Again, statistics is not that accurate because here we're taking the average of a group of data that's in a certain spread. So again, it's all the plus or minus rule of accuracy. So how do we find the midpoint of this data set? Yeah, take 75 plus 124 and divide by 2. So it's 199 divided by 2. 99.5. The next one will be 149.5. The next one is 199.5. 249.5 and 299. How did I know those values? Well, because each of these from this number to this number is how far? 50. So that means this number has to be 50. That means this number has to be 50. So I add 50, which is my class size. It just makes it much easier if you just add 50 to each point. So can you answer any of these so far? Right now? You can't do it now. We don't know that yet.
Huh?
We don't know that yet. We can, the only one we can answer just by looking at our frequency data is this last one. What is that one looking for? The dot? Mode. The mode, by definition, is the most frequently occurring. So who has the highest frequency? What's the highest frequency? 24. The frequency is this number here. The frequency is how many of those numbers fit in that domain. They're all the same size, yes, but this one has 24 of them. This one has 11. So my modal class, this is called the modal class. This is not a single value, it's a mode. It's a class of numbers. No. We're not looking at bimodal. We're just asking which one has the mode. We look for the highest frequency, and it belongs to this. So that's the modal class. That's the mode. How about our median? Can we find our median? How do we find our median? Add the frequencies. So it's 5, 10, makes it 50. There's 50 of them. $50 divided by 2 is 25. So what's the 25th number? What do we need to find? In order to find this, I need to find the 25th and the 26th numbers and divide by 2. I need a running total. So the cumulative frequency, this one's 11. Then if I add 24, I got 35, 45, 48, 50. For this one, you need the cumulative frequency. So where's the 25th and 26th numbers? You should only look at this column here. The cumulative frequency column. Where's the 25th and where's the 26th number? Well, look at it. 25, is it bigger than 11? Is it bigger than 35? No. Is 26 bigger than 35? Is 26 bigger than 35? No. So both the 25th, 26th are inside this class. So the class is that. The medial class. There's not much to it. It's just the running total tells you how many you have. Where's your 25th, 26th number? And yes, we could take it a little deeper, a little further. I don't know if this book goes into that. But right now, all I want is the medial class, the modal class. Now, to find the average. To find the average, we know we have n. We have to add up all of our data. So which column adds up all of our data? This one. F times X, the frequency times the mid class. So we take this times that. So it's 11 times 99.5. 24 times 149.5. 10 times 199.5. 3, 249.5. And 2, 299.5. You have to add up all those and then divide by 50, which is what we have. This is N. So this is 1094.5. 3588.0. 199.5.0. 748.5. 599.0. Add up all those. 25.0. So this is the frequency times the medial class, which is 8025.0, which gives us what? Seconds. Makes a lot of sense. Again, what you should do is when you leave here and create your own notes, create a formula sheet of what each of these columns are and how to find each of these column values. Because all this is plug and play. You have the data set. You have the frequency. You need to find the cumulative frequency, the midpoint of each of these classes, and take the frequency times the midpoint and gives you these, add them up to find the mean. Again, that's all it takes. You just have to know how to decipher what these things are asking us. That's why I throw you through those last two examples to y'all. This one had classes. The other one was just discrete data. So you can see how both of them are done. Here we go with critical thinking. Zip codes for the Gateway Arch in St. Louis, White House, Air Force Division of the Pentagon, Empire State Building, and the Statue of Liberty are those. Can you do anything with those numbers? Can you calculate them and find the average or anything? They're zip codes. You can't. They're not qualitative. They're not quantitative. They're qualitative data. So you cannot find the mean, median. You can find the mode. You see which zip code occurs the most, but you can't find the median. You can't do that. Ranks of selected national universities of Harvard, Yale, Duke, Dartmouth, and Brown, 2, 3, 7, 14. Can you find the average of those? Are they quantitative or qualitative? In other words, with Harvard is 2, Yale's 3. Does that mean they're ranked that, or does that mean that's their numeric value? They're ranked. So these are not numbers you can find the average. You can't take a Harvard and a Duke education and say somebody's got a Dartmouth education. It doesn't work that way. So just because you quantify the values, these are still qualitative data. You're qualitatively analyzing them. Numbers on jerseys, starting in Defense Seattle. Can you add up the numbers of jerseys and get somebody in the middle? No, they're qualitative. They're not quantitative. 5 incomes of chief executive officers. Can you find the average of those? Yes, because that's a quantitative. It means a quantity of something. 50 mean ages computed from the means in each of 50 states. Can you do anything with those 50 mean? They're taking the average of an average is not too safe. So because it gets you further away from the truth anyway. So be very, what this example sheet's all about is be very careful. If the numbers you look at are quantitative as opposed to qualitative, then you can calculate them. If not, then you can't do too much with them. The last thing we're going to do, calculating grade point average. In her first semester of college, a student of the author took 5 courses. Her final grades were along the course credits of each were. The A was a 3-credit course. They had a class with 4 credit hours. B was a 3-credit. C was a 3-credit course. And got an F in a 1-credit course. Can you have a 1-credit course? Yeah. PE. What else? What's that?
Intro.
To what? Oh, yeah, intro to college, stuff like that. Yeah. Again, any F hurts. You see how, even though there's only 1 point, it does add up in the end. The grade system assigned an A counts 4 points, a B counts 3 points, C counts 2, D counts 1, F counts 0. Find her grade point average. Calculate her grade point average. So the first one was a 3-hour course. The next one was a 4-hour course. The next one was a 3-hour course, 3-hour course, and a 1-hour course. The grade she got was an A, B, C, and F. So how many points do you get for an A? For a B, for a C, and for an F? So what 2 columns do we multiply to get the grade value? 3 times 4. So multiply A times B. Four times four is 16, 3 times 3 is 9, 3 times 2 is 6, 0. Now what do you do? I'd say it's a grade, you're finding the average of all the grades. So add up all these. Well, 21, 23. That's 43 points. Divided by what? No. No. How many hours did she attempt? This is the grade she got for how many hours were attempted. So 3 plus 3 is 6, plus 4 is 10, 13, so it's 14 hours attempted. Because what you're looking at, the grade is what did you accomplish over what you attempted. So it's 43 divided by 14. 3 is 42, so it's 3 point what? 3.01. 0.5. 71. So that's your GPA, your grade point average. So on the scale of things, what grade did she get for the semester? B. Because a B goes from 3.0 to 3.99. So actually it's a B minus for the semester. For giggles and grin, let's give her an A for her PE class. Unlike me, she could climb that rope in PE class. So let's try again now with an A in PE. So you got 4 points there. Instead of an F, she got an A. Yeah, so it changes to 47. .357, which is approximately 3.4, which is a solid B. Yes, it may not look like a lot, but what if you wanted to go to law school or medical school, where 1,000th of a point would kick you out? Or if you're applying for scholarship when they want 3.5 or above. Yeah, but you got 3.4. Too bad. So sad. Goodbye. So again, take this seriously. I mean, all your classes, take them seriously. All right, that's it for this section. Any questions?